how to make a shiny new 32GB USB flash drive using an old iPhone 5. Well, that's what I'm going to share with you today. If you're like me, you've probably got an old iPhone 5 lying around somewhere that is faulty or is no longer good to you as Apple have stopped supporting it through software updates. Maybe it's iCloud locked and you can no longer remember the passwords. There are millions of phones in this state that will be heading straight to the trash very soon, as new phones are coming out every month now. Don't bin that old iPhone just yet. Today I'm going to show you how you can recycle that old iPhone into a shiny new 32GB USB flash drive. It's a fun project in micro soldering and perfect if you have just bought your first heat gun and are looking for something satisfying to do with it. For today's project you are going to need two things. One is a Nand flash controller board or a uDisk, and you are going to need an old iPhone 5. Now, here's a bit of trivia for you. I remember when these iPhone 5s were first released in the UK, the 32GB version cost around £750, and I specifically remember that these were released in the UK before they were released in Japan, and people were buying them in the UK and they were putting them up on eBay for £950, and people from Japan were buying them like hotcakes. And today you can go on eBay, and I've picked these up for £5 to £10, and I'm not joking with you. The reason is that nobody uses, barely uses the iPhone 5 anymore, and I haven't had one come in for repair for years. So these are just sitting in people's drawers, and people have no use for them at all whatsoever. The parts are not needed anymore because, like I said, they don't come in for a repair. So you can pick them up for cheap as chips now, and total cost is probably going to cost you £10, £5 to £10 for the phone, and about £3.50 for one of these, including delivery. I'm going to tell you what this is in a minute. Now, I know somebody's going to come in the comments and say, well, you can buy a 32GB stick now for about £5 to £10, but that's not the point. Anybody can buy one, but how many people can make one? And what I like to do with these is I like to build them and I like to give them to people as gifts. So I've given some to my kids, and I like to give them to friends and family. I know it might sound strange giving somebody a USB stick as a gift, but when you tell them that you made it yourself or you compiled it yourself, put it together yourself, then it becomes something special and it has some sentimental value, and it's something that people can talk about as well. They say, oh, so and so gave me a USB stick and they made it themselves. So it's a nice little fun project, and let's get started. The second thing that you're going to need for this project is a flash controller PCB, or commonly referred to as a uDisk. Right, and what it is, it's basically a PCB with two spaces on it, one here on the front and one here on the back. And what you do is you remove the storage from the old iPhone and you install one here and you install one here. Okay, so if you installed two 16GB NANDs from an iPhone, from two iPhones, that will make it 32GB. If you install one 32GB NAND, then obviously that will make it 32GB as well. What I'm going to do now is I'm going to go over to the computer and I'm going to show you where you can source these uDisks from. If you come here into the search box and if you type in iPhone NAND uDisk, iPhone NAND uDisk, and what you'll have a whole host of them that will come up here, and they've got different versions here. For example, they've got the LGA 11, LGA 70, LGA 60, LGA 52, and these are for the different iPhones. For example, the LGA 52 is for the 4 to the 4S, the iPhone 4 to the 4S. The LGA 60 is for the iPhone 5 up to 6P. Okay, and that's the one that we're going to be using today, the LGA 60. And then you've got the LGA 70 board, which is for iPhone 6s to 7 Plus, right? And then you've got the LGA 11 0 board, which is for the iPhone 8 to the 11 Pro Max. So you've got different boards here. Okay. Now, as I say, the one that we're going to be using today is the LG A60. Now let's get back to taking this iPhone apart and getting access to the memory that's stored on the iPhone. Okay, so what we're going to do is we are going to disassemble this iPhone 5 and we are going to remove the Nand storage disks or storage drives from the PCB, and we are going to install them onto our uDisk. So the first thing that we want to do is, I'm not going to show you how to strip the iPhone, there's hundreds of videos to do that, but I'll just quickly take it apart in front of you and I'll show you where that NAND disk is located. So you're going to take your iPhone 5 apart. Okay, it doesn't matter if you're making any mistakes because we're not going to reuse anything from here. I mean, if the screen is still good, you can sell the screen, and if any of the parts. But as I say, hardly anybody's looking for parts for these now. They're going to become obsolete soon. What you then want to do is you want to remove this PCB here. Can you see this PCB here? And there's screws all around here. Okay, you'll have to get them off. Okay, and then eventually what will happen is this piece here will come loose, and this is the part that we're interested in. Okay, the NAND ICs that we want are located on the back of the board. Okay, so what we're going to have to do is we're going to have to remove this this protective metal board over here. Okay, we're going to heat this up under the microscope with a heat gun, and we're going to remove this board or this cover. Okay, and that will give us access to the NAND, which is underneath. So let's go back over to the microsoldering desk and let's start taking that off. Right, so we've got our iPhone 5 PCB clamped into our board, and what we're going to do is we're going to gently go around with a heat gun and we're going to heat up all around the edges of this metal cover, and we're going to remove it. Can you see where the solder points are? Around here and around here. You have points like this all around the board on the edges, and what we want to do is we want to heat them up and we want to take that cover off. So that's what we're going to do now. I'm going to set the heat to 380 degrees and I'm going to set the wind speed to about 40. So let's get started. And that's come off nice and clean. So if you have a look here, this is the board, and the IC that we're interested in is all the way down here to the left. This is the IC that we're interested in. It's called an iPhone NAND chip, and this is what we want to get off and install on our uDisk. So what we're going to do now is we are going to remove some of the glue which is located around the edges of this IC. Okay, they use a really nasty black type of adhesive around here, but if you know how to take it off, it's not too difficult. So I'm going to show you that now. So if you have a look here, this is a special tool that we use to remove the glue on the side of the ICs. Okay, and again, you can get these from AliExpress. They're quite cheap, they're not expensive at all. You can get a full set for about £5, I think, delivered to the UK. That's with the holder and a few different types of blades. So the idea is you come around the edges. Okay, you set your heat to 220 degrees and your wind speed to about 40. You can set that a bit higher, a bit lower, whatever you prefer, and then gently what you do is as you heat this up, you just scrape this away and all of that glue will just come off, it'll just fly off. So let's get started and let's remove that glue. Now normally I wouldn't be as aggressive if I was removing this to repair it, but because there's no other use for this board, it doesn't matter if I put a bit more pressure on it and you start seeing some of the copper underneath, because we're not really going to use this board for anything else, so we're just going to remove the Nand chip off it. But as I say, if you were going to repair this board, then you wouldn't put so much pressure because you don't want to reveal any of the copper underneath. Right, so we've managed to get most of that black pasted glue off now. So the next thing that we need to do is we need to now remove this IC from the board, and the way we're going to do that is we're going to apply heat to the top of this IC, and we're going to set the temperature on the heat gun to 370 degrees, and we're going to set the wind speed to about 70. Okay, and we're going to gently, in a rotating fashion, we're going to heat up this chip. And new tool alert, what we're going to do is we're going to be using this tool here. If you have a look here, can you see the blade on this tool? This is the tool, and this is the blade. And what we're going to do is, as we heat up the IC, the glue underneath and the solder will start to melt and get softer, and that will allow us to come in from the bottom here and gently get in underneath. Okay, and what happens is you slide it slowly, you slide it, okay, and eventually this chip, you should be able to just pop it off from the bottom. Now what I do like to do is I like to put a bit of flux on the top of the chip. You can put some on around the edges if you want, but I don't really bother with that, not when I'm just going to reuse the Nand and not going to repair the board. What I like to do is I like to apply a layer of flux on the top, and it acts as a heat sink and helps the chip from getting fried. So I'm going to do that now, and we're going to proceed to remove this chip. Remember, you don't want to force your tool under the IC, because then you might damage some of the pads on the IC itself and expose some of the copper either on the board or on the IC, which you don't want to do. So all it is, you just want to gently push. Once it heats up to the right temperature, it will go straight through like butter. Okay, so as you can see now, the tool is starting to slide into the bottom, and look how easily it goes in. Once it reaches the right temperature, it's not going to fight with you. It's going to go straight through. And it's off. If we put the IC here, you can see that we managed to get that IC off, and we didn't cause any significant damage. Okay, there's a little bit of copper exposed here, but that's fine. We can repair that, that's not an issue. We can put some solder mask over that, that's not an issue. But generally, this IC has come off quite cleanly. Most of the glue has been removed as well, so we won't have to do much prep work for it before we install it onto the uDisk. Right, so let's move over to the next section now, which is we're going to clean up this this IC, and we're going to get it ready to install onto our flash drive. Okay, so we've removed our IC off the PCB, the iPhone PCB, and what we're going to do now is we're going to put it into an IC holder or an IC vise, and we are going to clean off the rest of the glue, and if there's any exposed copper, we're going to put some solder mask over it, and it should be ready to go into the uDisk. So what we're going to use to secure this IC is a tool like this. This is called an IC holder or an IC vise, and what you can do is use it to secure different types of ICs, and it's perfect for this job. So what you do is you put it in here and you just tighten it up from both edges, and it's back to under the microscope. Okay, so I'm going to introduce you to a new tool here. This tool here, I call it a glue removing chisel, and it is used to remove, can you see the black glue that's remaining on the IC? It's used to remove that glue, and what you do is you gently just move it back and forth over the IC, and this glue will just come off. But there is something else that we have to do, and something else that I need to bring to your attention here as well. This glue here, it melts at about 220 degrees, the solder that's left on the pads, this solder here, if I'm correct, it melts at around 280 degrees. So what we have to do is we have to bring this solder, the melting point of this solder, the solder on these pads, down to around about the same melting point as this glue. Otherwise what will happen is, as we're chiseling away, the chisel will keep getting caught on the solder. But if you bring the solder melting point down to about 200 degrees, then what will happen is, as you're chiseling the glue, the remaining solder on the pads, they'll just chisel away as well, and it won't cause you any problems. So to do that, what we're going to be doing today is we're going to use some low melt solder, which I've got here. The low melt solder, you can get it off AliExpress. I'll just try and show you on the camera here, if I can. And this one here, there's a few different types of low melt solder that you can get. You can get one that melts at 183 degrees, which is good for applying below ICs when you're going to reinstall them. This one here is a very low melt one, and this one melts at 138 degrees. So what we're going to do is we're going to apply some of this low melt on top of here. We're going to put some flux, we're going to mix it up, and we're going to go over these pads with the soldering iron. And what that will do is that will bring the melting point of the solder on these pads down to about 180 degrees, which is what we want. So let's do that now. That should be enough. And now what we're going to do is we're going to put some flux as well. And then what you can do is you can get a toothpick and just mix it up a little bit. The reason why we use a toothpick is we don't want to cause any damage to the IC. Right, because if you get anything sharp and you start pointing it around here, then you might damage some of the pads underneath. So let's just mix that up a little bit. Clean up the top of this IC. Okay, I believe that's good enough. And what we're going to do now is we're going to proceed to clean the IC and remove the remaining glue and the remaining solder. So what we're going to do is we're going to set the heat gun to 220 degrees, and we shall set the wind speed to about 70, and we should be good to go. Can you see how the solder just comes off really easily? See, if you hadn't brought the temperature down, what would happen is the chisel will start catching on the balls. Can you see how I'm just going gently back and forth? I'm not putting too much pressure on the chisel. Just gently back and forth, back and forth. That's all it requires. And you can see it's all starting to come off. Okay, and I believe that's good enough for now. So to repair this IC, the first thing that we're going to do is we're going to come around here with some wick, and we're going to wick up as much of this solder as possible, and that will expose the copper pad underneath. And then what we'll do is we'll come around with some solder mask, and we shall cover the exposed area with some solder mask and apply some UV light to help it cure. So let's do that now. Be careful not to slide it too much. You just want to dab the soldering iron on, because if you slide it, what will happen is you'll end up taking more of the covering of the pad off, and you don't want to do that. You see just the way I'm just dabbing it gently. You won't be able to get it all off. There'll still be a thin layer, but we just don't want anything protruding. So when we apply the mask, it will go on easily and it will do its job. And that should be fine. Let's just quickly clean that up again with a Q-tip and some alcohol. Okay, so I'd quickly like to take a second to show you what solder mask looks like and explain what it's used for and what its purpose is and where you can get hold of it from. So what solder mask is, it's like a type of ink that you can use to apply to exposed PCB areas where the copper is exposed. And What you then do is you come over it with a UV light, and it cures and becomes hard. And what I normally do is I take the bottom off. Okay, can you see that here? Right, it's like a cup inside there, isn't it? I put a bit of solder mask inside here, okay, and I use a broken tweezer, just like this, or the half end of a tweezer, and I dip it into the cup, just like so, and then I'll apply that to different points of the board, wherever it's needed. So let's get back to the microscope and let's proceed to applying this solder mask. Now you need steady hands for this. Try and hold it with both hands and you should be alright. Just watch what I do here. Sometimes you have to come down at an angle if it doesn't come off the tip of the tool that you're using. And then what we do is we just gently flow it around to wherever we want it to go. Okay, so we want some more to come around here. Can you see when they describe it as an ink, what they mean? It's like a viscous liquid, and you just place it on wherever you want it to go, and you move it around with a sharp tool, and that's all there is to it. Okay, so we've applied our UV mask onto our IC, and now we want it to cure. And the tool that we're going to use to cure that solder mask is called a UV light, and this is what it looks like. It's got a switch. The other end just plugs into any USB power bank or power adapter that you've got. And it's got a light on the end here, and you can get these from AliExpress as well. They're not too expensive, but you definitely need one if you're going to do a lot of IC work or work on any kind of printed circuit boards in confined spaces. And what you do is you apply your mask and you put the light over the area where your mask is, and you switch it on, okay, and you leave it for about 30 seconds, and what that will do is that will cure the solder mask or the solder ink underneath, and it will make it hard, thereby protecting the exposed copper. Right, so we've switched on our UV lamp and we're going to place it over the mask area. So here goes. And what you can do, let's say if you want it to dry faster or you've got a large area that you've covered, you can also use your heat gun at about 200 degrees heat, and that will help it. That will help the mask dry faster as well. For such a small area, it's not necessary, and the lamp should be just fine. Okay, so we've finished with our UV light, and our solder mask is now cured. If you have a look here, can you see how it's gone hard? Can you see? Do you remember how it was runny before when I was running my pointy tool over it? But now it's actually cured and gone hard, providing the protection that we need. So as you can see, our Nand is now nice and clean and ready to be installed into our uDisk. Okay, so we have the uDisk here in front of us now, and I quickly want to make you aware of something before we move any further. This here is the flash controller IC, okay, and if you have a look, I'm trying to get these numbers an angle that you can see, there you go. It says here, it clearly says here SM3267L. Now, different flash controller ICs by different manufacturers have different software that you need to use to initialize the disk before you can use it as a disk. After you have installed your iPhone Nand, you have to use the specific software for this controller to initialize that disk and allow you to write information to it. Now, if you get the same one as I have here for the iPhone 5s, which is the LG A60 board, then you may possibly have this controller here, SM3267L. If you do have this controller, I have already sourced and found the software for this controller online, and I should leave a link for it below the video for you. So if you get this board, you can come to the video and click on the link and download that software. After I have installed the Nand onto this board, I should show you how to use that software to initialize that disk. Okay, so remember what I said about installing the first Nand on the same side as the flash controller. Okay, if you install it on the other side, it won't work. If you've only got one IC, it needs to be installed on the same side as the flash controller. If you've got two, obviously you'll populate both sides of the board. And another point that I want to mention here as well is that if you notice here, there's a little arrow here. That means that this is where pin 1 needs to be located. So if you have a look on the IC, let's get the IC here. Right, I've got the IC here. If you have a look here on the corner of the IC, can you see a little dot here? That indicates pin 1 is located in this region here. Okay, so that matches up with the arrow underneath, and that's how you want to install it. Now, before we go ahead with this, what we want to do is we want to put some flux onto the pads here, which will help the solder melt and help the IC adhere to the board. So we're going to do that now. Then what you do is you get your IC and you sit your IC on top, like so. Okay. If you want to see where the balls are, just to help you line it up, what you can do is you can put it upside down here, and that tells you that you need to be a slight distance away, because if this ball is here and this ball is here, then you need to be about that much away from that line here. Okay, that'll be just right. Can you see what I mean about the alignment? So you don't want to be right on the line, you want to be a little bit further away from it. Okay, so that's fine. So what you do is you put your IC around about here. Now I want to show you the technique, what you're going to do. Once you start to heat this up, we're going to use about 380 degrees of heat, and the wind speed we're going to set it to about 70. Okay, once you heat this up, what you're going to do is it's going to start moving about a little bit, so you might have to nudge it about a little bit with your tool, whatever you're using. I'm just using a one side of a tweezer, a sharp tweezer, and just try and keep it within that square here. Now what will happen is, as the balls melt underneath, they will adhere to the IC, and the IC will automatically go into its place, wherever it wants to go. Okay, and what you do is, once you get it up to temperature, you just nudge it a little bit like this from the side, like see how I'm nudging it, and it will come back. So each time you nudge it a little bit, it will come back into place, and that just tells you that the solder balls have made contact with the pads underneath the IC, and everything is functioning as it should. So just remember that technique. Once you get it up to temperature, just give it a little nudge, a little nudge, a little nudge, and it will just keep coming back, and that means everything has adhered correctly. And we're done. Okay, so what we're going to do now is we're going to get a little toothbrush, and we're going to dip it in some alcohol, and we're going to clean up this PCB just to remove any flux residue that's left on the board. So as you can see, we have cleaned off all the old flux residue off the board, and it's come out nice and clean now. Now what you want to do at this time as well is just inspect this area of the board to make sure that when you were heating it up, you never loosened any of the other components, like the resistors or the capacitors. What you can also do, actually I should have mentioned this earlier, is cover this bit. While you're working on it, maybe just use a piece of metal and just cover this like so, and that will help you as well protect the other components on the board. But that's fine now. It's ready to go into the PC and to find out if everything worked. Okay, so we're back at the computer now, and I want to show you the software that you're going to need to initialize this disk. So if you have a look here, the link that I'm going to leave for you below the video will be the link for this raw file here. It's called SM3267AE-Q0207B2.raw. So that link will give you a download for this file here. Once you've downloaded this file here to your computer, you will extract it, and from that extraction you will receive this folder here. Okay, now once you click into this folder, you click into it again, and you come all the way down here, and you'll see here it says SM32 xtest-v54-6.exe. You're going to double click on that, and that's going to open this software here. Okay, this is the initialization software. Now what we're going to do is, you're not going to see this, but I'm going to tell you. I'm going to put the flash drive into one of the USB ports of the computer, and it should show up here. So let me just do that now. As you can see, the software has recognized that we have installed a uDisk with a 32 gigabyte Nand, and all you have to do now is you just press the start key here, and it will start to initialize the Nand IC for you and prepare it so you can start copying files to and from it. So here goes. It says the pre-test will erase all bad blocks. Do you want to continue? Yes, we do. Give it a couple of seconds to do its thing, and it should be ready for you any moment now. Okay, so as you can see here, there's a big green OK written here. That means everything was fine, and everything went through successfully. Okay, and our disk is now ready to write files to. So we can close this application, and what we're going to do is, if you go back into your directories here, right, if you come here, you should see that there is a 32 gigabyte disk, USB disk here. So just to test it and just to make sure, what we're going to do is we're going to write a 100 megabytes file to this disk and make sure it's functioning correctly. So just give me a second while I do that. This file here, Liquid Motion 1080p, is 97.9 megabytes. So what I'm going to do now is I'm going to copy that, okay, and I'm going to paste it onto the disk, and this will let us know if the disk is functioning correctly. And there you have it. That was quite fast. And that, my friends, is how you create your very own 32 gigabyte USB flash drive using old iPhone parts. Well, that's it for today, and I hope you enjoyed this video. Don't forget to like and subscribe, and please do leave a comment down below if you've got something to say. Bye for now, and have a nice day.